Thank you.
Thank you. Our next speaker is Neha Shinde, who's an intern at Castalia Research Labs, Pune. She's going to be talking about a prototype of a 3D scanner system using Python.
Yeah. Hi everyone, I'm Neha from Castalia Research Lab. I will share some idea about 3D scanner system which I have been implemented till now. It is still ongoing project. This will be the outline of my presentation. Like these are the some points. Like motivation behind this 3D scanner system is like we live in 3D world and we perceive the things 2D, but our our algorithm, like our brain has an algorithm that can detect the depth for an image so that we can see a world in a 3D image. But in case of like artificial intelligence, a camera can see the world in 2D things. But the need is like to enhance its intelligence, we need a 3D data so that we can improve its intelligence. My objectives behind this project are like to construct a 3D structure from 2D sequence of images. I have captured sequence of images, 2D images, and constructed them into 3D world. And next is the to analyze the mismatch between reconstructed world and the real world. Like I'll give a short presentation like what I have done, not on the theory and everything. Like the softwares and tools that I have used are like for the operating system I have been used is like Ubuntu, and language is of course Python, and libraries I am using is OpenCV, NumPy, Matplotlib, and Tkinter. OpenCV for computer vision that I am using, and NumPy for mathematical calculations, numerical Python. NumPy I am using. Matplot is Matplot library. Basically I am using for plotting the things in 3D format, and I think that is sufficient. As of now, there are many options to plot the 3D things, but as of now I am using Matplotlib and Tkinter, of course UI, graphical user interface. The system setup is very simple. Like it has a rotating platform, a camera, a controller, and a background with a proper light. Like I'll visualize the things. Like there is a rotating platform. Behind that there is a light with a proper light, and in front of rotating platform there will be a camera to capture the image, and of course a controller to control the stepper motor to rotate the object. So basically idea is like I'm like to rotate the object is like to cover the view of that object in 360-degree angles. Like this is the setup. The methodology that I am using is like first is capturing images. Basically behind this project, like to capture a 2D image, I am using a UVC camera to capture an image, and after capturing image, I need to segment the desired data. That like if I place an object, I need an object, and the other background should be null. Like there should not be anything in the background. So for that segmentation, I use thresholding, color thresholding. Like like basic problem in color thresholding is that if the color of an object changes, for object to object it has different colors. So we cannot change the threshold value every time. So for that, like we are projecting a light behind the object so that we'll get the threshold value near to zero, like near to black values. So this will solve the problem of thresholding. And next is feature detection. Like for feature detection, I have used like this fantastic function like contour detection. The contour detection will give me the value x and y. Suppose if this is the object, this is the center of rotating object. I have segmented the object with like contour will give me what x and y values. Well, x and y values for each point. This x and y. For a single image, I have n number of points like x and y. Then what all I have as x, y, and as well as theta for like I am rotating the object at equal steps of angle. So I have y and theta. With this, for a single image, with this data, what I did is like it converted into x, y, z. Like x is equals to x, like this x into sin theta. Y I kept it as a height, and z is x into cos theta. So I have got x, y, z for single image. So for n number of images, if I capture 50 images for an object, so I have 50 such images with x, y, and z data. So next thing is like to club all the data. So I created n-dimensional array. I have stored I have created n-dimensional array which will store the XYZ data for every image. So like this is for 50. I have created a array like which in a single layer which I will have XYZ data for first image, for second image. Likewise, for 50 images I will have the data. Then simply I plotted this data using matplotlib 3D projections, and here are some results. Like this is the object that I have segmented out. This is a simple pen cap. The contour detection for the same. With this image, this is the 3D thing that I have got with the plotting of the images. This is like simple 3D 3D plotting. Coming to the application, it has a number of applications like in machine intelligence, in 3D printing. We don't need to manually plot the things with another tools. We can make the system automated, like scanning and giving and printing the data. And of course, quality inspection. If we have 3D data, we'll have better quality inspection. Like the further works, like this is still like work in progress project. Like there are some mismatch between real world and reconstructed world, and as well as it works fine for like cylindrical objects, such as if you take a cup, it will work fine. If you take apple, it will work fine. But the thing that I have noticed is that for the square object, it will not work. So there are many algorithms, like in Python also we have library regarding stereo matching. Yes. For sequence of images, we can map a disparity map for two images, and likewise for a sequential images, n images, we can plot a stereo thing, and we can construct a 3D world. Yeah, that's it. Thank you.
Any questions?
Hello, great talk. I was wondering, how are you handling like the occlusions or the hidden surfaces?
Sorry?
How are you handling the hidden surfaces of the object?
Yeah, that is one problem that I have faced also, that I have to work on that. Like,
And like, what is the between successive images? What is your like theta, theta, like delta theta?
sorry?
Like between successive images, what is your delta theta?
Theta for this I am keeping is 1.8.
1.8. Any reason for like? taking
No,
one?
like if we have n number of, like we have more data, we'll have more accuracy. So for we can rotate the stepper motor according to our need. Like,
Thank you.
The question was that how would you get the points of the upper end? That means in 3D dimensions they are you can go for the 8 views, or 6 views, top and bottom also. The question was same, that how would you get the top and bottom so it will
Yeah.
completely make the 3D object.
yes, we will have to work like.
Yeah.
Okay then, thank you.